Isopropyl alcohol is a chemical compound with the molecular formula C3H80 or C3H70H. It is a colorless, flammable chemical compound with a strong odor. It is the simplest example of a secondary alcohol, where the alcohol carbon atom is attached to two other carbon atoms, sometimes shown as 2CHOH. It is a structural isomer of propanol. Isopropyl alcohol is denatured for certain uses. Properties: isopropyl alcohol is miscible in water, alcohol, ether and chloroform. It will dissolve ethyl cellulose, polyvinyl butyryl, many oils, alkaloids, gums and natural resins. It is insoluble in salt solutions. Unlike ethanol or methanol, isopropyl alcohol can be separated from aqueous solutions by adding a salt such as sodium chloride, sodium sulfate, or any of several other inorganic salts, since the alcohol is much less soluble in saline solutions than in salt-free water. The process is colloquially called salting out, and causes concentrated isopropyl alcohol to separate into a distinct layer. Isopropyl alcohol forms an azeotrope with water, which gives a boiling point of 80.37 AA degrees Celsius and a composition of 87.7 Wt% isopropyl alcohol. Water isopropyl alcohol mixtures have depressed melting points. It has a slightly bitter taste, and is not safe to drink. Isopropyl alcohol becomes increasingly viscous with decreasing temperature. At temperatures below 70 AA degrees Celsius, isopropyl alcohol resembles maple syrup in viscosity. Isopropyl alcohol has a maximum absorbance of 204 nm in an ultraviolet visible spectrum. Reactions: isopropyl alcohol can be oxidized to acetone, which is the corresponding ketone. This can be achieved using oxidizing agents such as chromic acid, or by dehydrogenation of isopropyl alcohol over a heated copper catalyst, CH3, 2CHOH or 2CO plus H2. Isopropyl alcohol is often used as both solvent and hydride source in the Moe-Wayne-Pondorf-Verley reduction and other transfer hydrogenation reactions. It is oxidized to acetone. Isopropyl alcohol may be converted to 2-bromopropane using phosphorus tribromide, or dehydrated to propane by heating with sulfuric acid. Like most alcohols, isopropyl alcohol reacts with active metals such as potassium to form alkoxides that can be called isopropoxides. The reaction with aluminium is used to prepare the catalyst aluminium isopropoxide. Production: in 1994, 1.5 million tons of isopropyl alcohol were produced in the United States, Europe, and Japan. This compound is primarily produced by combining water and propane in a hydration reaction. It is also produced by hydrogenating acetone. There are two routes for the hydration process: indirect hydration via the sulfuric acid process, and direct hydration. The former process, which can use low-quality propane, predominates in the USA, while the latter process, which requires high-purity propane, is more commonly used in Europe. These processes give predominantly isopropyl alcohol rather than 1-propanol because the addition of water or sulfuric acid to propane follows Markovnikov's rule. Indirect hydration: the indirect process reacts propane with sulfuric acid to form a mixture of sulfate esters. Subsequent hydrolysis of these esters by steam produces isopropyl alcohol, which is distilled. Diisopropyl ether is a significant byproduct of this process. It is recycled back to the process and hydrolyzed to give the desired product. Direct hydration: direct hydration reacts propane and water either in gas phase or in liquid phase, at high pressures in the presence of solid or supported acidic catalysts. Higher purity propylene tends to be required for this type of process. Both processes require that the isopropyl alcohol be separated from water and other byproducts by distillation. Isopropyl alcohol and water form an azeotrope, and simple distillation gives a material that is 87.9% by weight isopropyl alcohol and 12.1% by weight water. Pure isopropyl alcohol is made by azeotropic distillation of the wet isopropyl alcohol using either diisopropyl ether or cyclohexane as azeotroping agents. Hydrogenation of acetone, Crude acetone is hydrogenated in the liquid phase over Raney nickel or a mixture of copper and chromium oxide to give isopropyl alcohol. This process is useful when coupled with excess acetone production, such as the Cumin process. Uses: in 1990, 45,000 tons of isopropyl alcohol were used in the United States. The vast majority of isopropyl alcohol was used as a solvent for coatings or for industrial processes. Isopropyl alcohol in particular is popular for pharmaceutical applications, it is presumed due to the low toxicity of any residues. Some isopropyl alcohol is used as a chemical intermediate. Isopropyl alcohol may be converted to acetone, but the Cumin process is more significant. In that year, a tiny fraction was consumed for household use and in personal care products. It is also used as a gasoline additive. Solvent: isopropyl alcohol dissolves a wide range of nonpolar compounds. It also evaporates quickly, leaves nearly zero oil traces, compared to ethanol, and is relatively non-toxic, compared to alternative solvents. Thus, it is used widely as a solvent and as a cleaning fluid, especially for dissolving oils. Together with ethanol, and butanol, and methanol, it belongs to the group of alcohol solvents, about 6.4 million tons of which utilized worldwide in 2011. Examples of this application include cleaning electronic devices such as contact pins, magnetic tape and disk heads, the lenses of lasers in optical disk drives and removing thermal paste from heat sinks and IC packages. Isopropyl alcohol is used in keyboard, LCD and laptop cleaning, is sold commercially as a whiteboard cleaner, and is a strong but safer alternative to common household cleaning products. It is commonly used to clean prepared optical fibers just before splicing. It is used to clean LCD and glass computer monitor screens, and used to give second-hand or worn non-vinyl phonograph records newer-looking sheen. It is effective at removing hot melt adhesive from a large variety of surfaces. It is effective at removing residual glue from some sticky labels, although some other adhesives used on tapes and paper labels are resistant to it. It can also be used to remove stains from most fabrics, wood, cotton, etc. In addition, it can also be used to clean paint or other oil-based products so that they may be reused, commonly known as repainting. It is used as a wetting agent in the fountain solution used in lithographic printing, and often used as a solvent for French polishing shellac used in cabinet making. Intermediate: isopropyl alcohol is esterified to give isopropyl acetate, another solvent. It reacts with carbon disulfide and sodium hydroxide to give sodium isopropylengate, a herbicide and an off-flotation reagent. Isopropyl alcohol reacts with titanium tetrachloride and aluminium metal to give titanium and aluminium isopropoxides, respectively, the former a catalyst, and the latter a chemical reagent. This compound may serve as a chemical reagent in itself, by acting as a dihydrogen donor in transfer hydrogenation. Medical: disinfecting pads typically contain a 60–70% solution of isopropyl alcohol in water. Water is required to open up membrane pores of bacteria, which acts as a gateway inside for isopropyl. A 75% VV solution in water may be used as a hand sanitizer. Isopropyl alcohol is used as a water drying aid for the prevention of otitis externa, better known as swimmer's ear. Early uses as an anesthetic: although isopropyl alcohol can be technically used for anesthesia, its many negative drawbacks prohibit this use. Isopropyl alcohol can also be used similar to ether as a solvent or as an anesthetic by inhaling the fumes or orally. Early uses included using the solvent as general anesthetic for small mammals and rodents by scientists and some veterinarians. However, it was soon discontinued, as many complications arose, including respiratory irritation, internal bleeding, and visual and hearing problems. In rare cases, respiratory failure leading to death in animals was observed. Automotive: isopropyl alcohol is a major ingredient in gas dryer fuel additives. In significant quantities, water is a problem in fuel tanks, as it separates from the gasoline, and can freeze in the supply lines at cold temperatures. Alcohol does not remove water from gasoline. Rather, The alcohol solubilizes water in gasoline. Once soluble, water does not pose the same risk as insoluble water, as it will no longer accumulate in the supply lines and freeze. Isopropyl alcohol is often sold in aerosol cans as a windshield deicer. Isopropyl alcohol is also used to remove brake fluid traces from hydraulic braking systems, so that the brake fluid does not contaminate the brake pads, which would result in poor braking. Laboratory. As a biological specimen preservative, isopropyl alcohol provides a comparatively non-toxic alternative to formaldehyde and other synthetic preservatives. Isopropyl alcohol solutions of 70–99% are used to preserve specimens. Isopropyl alcohol is often used in DNA extraction. It is added to a DNA solution in order to precipitate the DNA into a pellet after centrifuging the DNA. This is possible because DNA is insoluble in isopropyl alcohol. Safety. Isopropyl alcohol vapor is denser than air and is flammable with a combustible range between 2 and 12.7% in air. It should be kept away from heat and open flame. Isopropyl alcohol has also been reported to form peroxides, which may explode upon concentration. Isopropyl alcohol is a skin irritant. Toxicology. Isopropyl alcohol and its metabolite, acetone, act as central nervous system depressants. Symptoms of isopropyl alcohol poisoning include flushing, headache, dizziness, CNS depression, nausea, vomiting, anesthesia, and coma. Poisoning can occur from ingestion, inhalation, or absorption. Therefore, well-ventilated areas and protective gloves are recommended. Around 15 ag of isopropyl alcohol can have a toxic effect on a 70 kg human if left untreated. However, it is not nearly as toxic as methanol or ethylene glycol. Isopropyl alcohol does not cause an anion gap acidosis unlike ethanol and methanol. Isopropyl alcohol does, however, produce an osmolar gap between the calculated and measured osmolalities of serum, as do the other alcohols. Overdoses may cause a fruity odor on the breath as a result of its metabolism to acetone, which is further metabolized to produce the nutrients acetate and glucose. Isopropyl alcohol is oxidized to form acetone by alcohol dehydrogenase in the liver. Isopropyl alcohol is denatured for certain uses, in which case the NFPA 704 rating is changed to 2, 3, 1. History. In 1920, Standard Oil first produced isopropyl alcohol by hydrating propane. Its major use at the time was not rubbing alcohol but for oxidation to acetone, whose first major use was in World War I for the preparation of the smokeless propellant, cordite. References. External links, CDC Euro-UNIOSH Pocket Guide to Chemical Hazards, Environmental Health Criteria 103, 2-propanol.